Hello everybody. So we're at our last talk today for the Front End Convenient Conference. Yay! We have the amazing Rich Kuzsma to give us a talk on hacking HipChat with React, GraphQL, and AWS. So hand it off to him.
Thank you, Jesse. Thank you folks for coming to this talk. My name is Rich Kuzsma. I'm an engineering manager and a fan of coding. All right, so let's talk about HipChat. Yeah, it gets the job done, right? But what I really want are the ability to tag and filter specific messages. I want to be able to reply to certain messages and thumbs up our private GitHub PRs right from the HipChat window. I want to be able to react and vote to messages with emoji, and I want to use GitHub flavored Markdown when I'm writing my chat messages, so I can embed my code with backticks like normal people do. But we have no plans to adopt Stride or Slack or Zulu, as far as I know. And HipChat's really been in maintenance mode since like late 2016. So I rolled up my sleeves and built CornChat. It's an app that hacks. It's an app that acts Atlassian's web and Mac HipChat clients to bring us all of those features. And I learned a ton along the way about React and Apollo and GraphQL and AWS Lambda and Cognito and Dynamo and CloudFormation, and the list goes on. And the state of modern JavaScript development tooling along the way. So first, I'm just going to give you a quick demo of what CornChat looks like. So I'm going to show this here on the web client. So here I have my web client loaded. I've got CornChat installed in there, and I'm on this chat room called CornChat. Please don't post anything there. So this is live. And what I can do from here is go ahead and click on this little corn icon, and here I can react to individual messages with emoji. So there we go. It's a ta-da. And because I'm the only one voting on these things, I can only add and withdraw my reaction. But if you had CornChat installed, you could come in here and also add your own reactions. I can also tag specific lines with a tag name. So for example, I've tagged this line as tips, and if I had multiple lines tagged as tips, I could click on the tag and essentially filter by that threaded conversation. I can go ahead and do a show all. So if you wanted to tag all your pull requests with PR, and you can filter by PRs and know where are the current open PRs. You can thumbs up, thumbs down. Also, I have at the bottom here some examples of, here's JavaScript syntax highlighting. You can have Ruby highlighting. And it's just using one of the common Markdown parsers here. You can turn off the Markdown and see that's the code that I write, and out comes Markdown. So that is CornChat. Now, in the next 55 minutes or maybe less, I hope to teach you a little bit about how to hack a native Mac app. And I want to introduce you to React and some really cool AWS technologies that you can use right now. You'll learn all about GraphQL queries and mutations and subscriptions, and we'll close with how to cure cancer. So just a side note, some of the material that I'm going to show could be a bit technical and dense. If you're having trouble staying focused, one of the tricks that I use to pay attention in really boring meetings is to purposely force myself to think of one or two questions that I would want to ask the presenter. So if you take nothing else away from this talk, maybe that little brain trick is worth the entrance fee. All right, so let's get started. So how did I build CornChat? Let's get under the hood here. I first started around by poking in the HipChat app. It's a .app file, and on a Mac, those are just Unix directories in a special format. You can drill into them and open them and see the contents. So I was looking through all the files, and I found this 7 megabyte chat.html file, and I'm like, jackpot! It is a web app. It's HTML and JavaScript and CSS. The whole HipChat Mac client is just a native wrapper around the web app. So I started small. I started adding some alert messages in there and some console log messages. I started breaking things and playing with it, and, just kind of learning how HipChat works underneath. And I concluded that this is totally hackable. Now, at first, I wrote CornChat as one large JavaScript file, just embedded right inside that HTML there. I used jQuery and global variables and embedded chunks of HTML and no ES6 and state mutations all over the place. And yeah, this is like way too many WTFs per minute. And writing JavaScript like that is like writing JavaScript in 2009. Coincidentally, that's the year some dude got fed up and wrote CoffeeScript. So, I digress. So I wanted to be able to split up my code into different modules. So I started out by adding Webpack 4 to my CornChat project. So I could split everything out and have a single releasable JavaScript bundle that I could shove into that HTML page. What's Webpack, you ask? Well, it's really indistinguishable from magic. You drop a JS config file into your project folder, you run npm install webpack, you run webpack, and through all sorts of magic, it is able to compile up all of your CSS files and JavaScript files and imported packages and images if you want, and it bundles them all up into one glorious JS bundle that you can literally just drop on your page with a script tag, and voila, everything works. Webpack even comes with a nifty Express dev server that serves up the JavaScript bundle, so you can import it right onto a page and test it out. Cool, so I added Webpack. Now my code is modularized. I have a dev server running with hot reload enabled, so every time I make a change, the HipChat app reloads everything inside it. And my dev test cycle is really speeding up. I'm starting to enjoy it. And just a side note about Webpack, I found that it really kept pace with all the different use cases that I ended up throwing at it. I mean, later on, I would go on to build AWS Lambdas, and I would actually use Webpack to build bundles of my Lambdas so I could take advantage of more modern JavaScript functionality. And it just did a great job. Plus, since I'm officially using Webpack, I now feel a lot better wearing my Webpack t-shirt on Wednesdays. But even with my wonderfully modularized code, the code itself was still littered with HTML vomit like this. So the first thing I did was search Stack Overflow for the right Webpack incantations that I needed to put in my config so that I could get ES6 support in my code. And lo and behold, ES6 really cleaned things up a bit. It's way more pleasurable to write things in. Multi-line string interpolation is great. Arrow functions are great. And just a side note here, a shout out to the Galileo team for teaching me about optional chaining. Optional chaining is an upcoming JavaScript proposal where it lets you write more concise conditionals, like what's up here. And you can get this feature before it's officially in the language spec just by adding more Webpack magic into your config, some Babel presets, and you're ready to use it. But back to the previous slide. So here's my ES6 code. Looks a little bit better, but I really wanted to pull all those HTML fragments out and properly separate the presentation logic from the rest of the app. Enter React. For the longest time, I hesitated to dive into React, mainly because of the whole Facebook patent licensing clause thing. Doesn't matter, that's like long been resolved. They finally realized the error of their ways. And also, I know that we've been talking here, especially in front-end guild and hallway conversations, we've been talking a lot about trying to move Constant Contact to a different front-end framework, like maybe React or Vue.js. So I thought this would be a really fun challenge. And it would be a great test of how well React can interop. Because, let's be honest, I'm building like a Trojan horse inside of a native Mac app in a non-Chrome-like WebKit sort of browser. So if React can work in this thing, it might have a chance at actually working inside of a Constant Contact web app. So what's React? I mean, in short, it's a view layer for JavaScript. Now, I'm not going to give a tutorial on React, but I will show some of the highlights of it and some design patterns that I learned along the way that I found especially effective. And maybe there are even some parallels in what we do here in front-end development and some lessons that we can take away in how to structure our own code, even if we're not all in on React. So let's walk through an example Cron Chat feature and show how it works in React. So here I'm in Cron Chat, and I'm going to I'll show you the feature to add a reaction to my to a HipChat message. So basically, I come in here and I click on a reaction, and boom, there it appears. And if I'm the one who has voted for the reaction, I can remove my reaction. It also makes sure that I can only vote once. Other people can vote. There's a count, etc. But suffice it to say that the reaction at its core is just a little bit of HTML that has an emoji and a count, the number of times somebody voted. So I want to at least extract that piece out of my application. I want to create a React presentational component that just does that. Just show me a hard-coded, heart eyes emoji on there with the count. So what does that look like? The code looks a little bit like this. Now this is what we call a presentational component in React. And it's really just like a dumb HTML tag with props. And props are like HTML attributes that you define for your component. Now this example, I've created a React class. There's multiple ways you can write React. In this instance, I use a class, which has a constructor, and this one big render method that just outputs the HTML I want to render. I won't get into JSX and how I'm able to put tags in here. If you're really interested in React, I'd recommend learning about that. But just suffice to say, this is just a dumb presentational component where if I feed it an emoji and a count, I will get a really pretty picture to appear on my page. If this were my entire React app, it would look something like this. I would import my reaction component from that JS file. And then I would go and inject a div onto an arbitrary HipChat message line. So you think about this. I've got reactions on every HipChat message all the way down. So this is just some jQuery code that throws a container div on the page, and I call this React render method to say, throw my component right inside that div. And wonderful, it works. But in reality, Cron Chat actually renders into the root of the HipChat DOM. And I create what React calls portals. These are all these purple dots you see scattered throughout the page. I created portals all over HipChat so that I could render components into specific DOM elements. Now I've got some absolutely positioned components, like there's a settings dialog that pops up when you click the Cron Chat logo. Those, it doesn't matter where you parent those in the DOM, they're just absolutely positioned. But for the other things like tags and emojis, I literally needed to embed those in specific places of the HTML. So using portals, really the beauty of that is it allowed me to separate where the components render from what and when they render. All right. I applied two other React patterns in this emoji example that I found especially useful. One is that I created what's called a container component to keep the persistence logic. How do I fetch those emojis from a database somewhere? From the presentational component, just how do I display it on a page? Now a container component is a React component that doesn't show any UI, it just fetches it, just the data. And the presentational component you can think of as just a dumb div, no logic there at all. Then I applied what the React gurus out there are calling the render props pattern. This is a way of explicitly chaining together container components and presentational components with a very explicit interface. So the way this works in this example is I have a function, I arbitrarily named it render prop. I pass that function to my container component, and when that container component fetches all the emojis, it will invoke this function and pass the result. In this case, an emoji and a count. So I can take those emoji and count values and pass them down into my reaction component. So it's a pretty cool pattern, and it really allows me to keep my container components very isolated from the rest of the code, my presentational components very isolated, very much in the sort of pure function style of functional programming. And if you take this to extreme, you end up pushing all of this logic for how to stitch together everything. You end up pushing it all the way up to like the root of your application. So actually look at the app, the actual CornChat app.js file. You don't need to read all of this. I'm just going to scroll up and down. But suffice it to say, my app is just one big render function. And I just I stitch together all of my container components and presentational components all the way down and then all the way back. There's all the coding text. I'm sure there's a better way to make it prettier. It's nice. I can clearly tell here what the interfaces are, what are the contracts between all these components. Everything is explicitly defined. I'm rarely using any global context or other things. It's easy to pull pieces out and plug other pieces in. It makes this thing entirely testable too. All right, but back to the example. I talked about emojis. I just glossed over really quickly the container components in there, which really gets the question of persistence. When I think about emojis, I want to be able to persist. For every HipChat message, I want to store the HipChat user ID that created that reaction, and I want to store the emoji that they applied with it. Now in HipChat, if you go poking around the DOM, you'll see that every message has this UUID in there. So I just lifted that off the page and said, let's store that. Let's store the other elements I could get right out of there. But how am I going to actually store all of this stuff? And usually around this time, this is just about when every side project dies or vanishes into obscurity, especially a ridiculous HipChat UI add-on. So I looked at a few different options. I looked at Google Firebase, looked at actually just trying to store everything into a chat room. Serialize. It's really cheap. I'm sure Atlassian would love that. But I ended up settling on DynamoDB because the price was right. I mean, you get 25 gigs of storage free. You can do 25 reads and writes per second, up to 200 million requests a month. I'm like, that's great. My AWS spend last month using CornChat was, just for this component, was $0. So, awesome. All right. Dynamo looks cool. How does it work? Well, if you log into AWS, and by the way, you guys can get AWS accounts you can, through Constant Contact, or if you don't mind, I actually recommend just getting your own AWS personal account. They don't cost anything. It's just based on what you use. So I recommend setting one up so you can play around with all these technologies and see how they work. So if you log into the AWS console and you click on DynamoDB, and it gives this interface where you can just go right ahead and start creating database tables. So I went and created a table called test CornChat message info. If I click on create item, I can input right in here some JSON. This is perfect. This is exactly what I wanted to store. I wanted some message ID. I wanted an array of reactions with the emoji value and the user ID of the person that wrote. Really simple, so easy to get set up. And you can actually invoke DynamoDB directly from JavaScript in the browser by hard-coding your AWS credentials. Now, especially on a side project, it's really tempting to do this, even though we all know this is a very, very bad idea. But why do we even contemplate doing something as crazy as that? And because the right answer here always means authentication. Yeah. Authentication is such a pain. And why? Why is it so hard? Well, because as Jesse reminded us last week at the engineering lunch, authentication means usernames and passwords and encryption and login forms and a whole host of things that are not what we're trying to build. So, I wish I could say that I found a silver bullet for authentication. AWS's answer to this is a tool called AWS Cognito. And it definitely helps. If you're building a web app, a typical web app, where you just want someone to sign in with your Facebook creds or your Gmail creds, they've got a lot of things really figured out. The patterns are very well defined, especially if you're using something like Angular or React. They've even figured out all the workflows for like login and sign up and unsubscribe and everything all the way through. You just plug in your styles and your markup and you're good to go. But when you stray off the beaten path, which you inevitably will, it's pretty rough around the edges. I mean, in my case, the HipChat Mac app, its browser, for some reason, sets the default charset header to a lowercase UTF-8, so it hard codes it in there. And so this conflicts with some expectations in the AWS Amplify authentication library, where it tries to do like digital signing, and it doesn't check some of the headers. It's like, something's wrong. It must be, must be hacked or something. And so it throws these really cryptic error messages, and you have no idea what's going on underneath. So it can take a while to sort that stuff out. Plus, it feels like there's like one engineer working on this. When you look at the GitHub repo, and he's a great engineer, and he's really responsive, and he usually tests his code. There's usually automation in there sometimes. But the libraries are really on the bleeding edge. It's just a couple of months old, so tread carefully. That's all I can say when it comes to authentication and some of these built-in AWS libraries. All right. So how does authentication work in CoreChat? Well, CoreChat's running in the browser. It's running in HipChat, so it has access to all of HipChat's global state. Like I can access your user ID, I can get your OAuth token, I can do anything with HipChat. Yeah. Really handy if I want to try to use your HipChat to verify that you are who you say you are. I didn't want to go build my own login and have my own usernames and passwords. I'm like, you already signed into HipChat, just use that. So CoreChat will get your user ID and auth token, and it sends it to a custom AWS Lambda function I wrote, cleverly called authenticate. And the Lambda function then takes that information and it reaches out to HipChat directly, and it says, I've got an OAuth token, I've got a user ID, is this legit? Is this who they say they are? And if it validates correctly, the Lambda then says, great, you're good. I'm now going to go ask AWS Cognito, could you get me an AWS token, just a temporary one, maybe an hour long. Give me a token that has access to that DynamoDB. Pass it back to CoreChat. CoreChat's like, great, cool. Now I can go and hit AWS DynamoDB. I'm authenticated, and now I know I'm a legitimate HipChat user. Cool. But there's some big issues with that. One that you probably already figured out is this exposes literally like read and write access to the actual Dynamo table. So clever CoreChat users among you will quickly figure out how to do multiple votes for message lines, or you can probably like write nulls on all of my messages and essentially nullify everybody's tags. And that's annoying, but I didn't care that much about that. But what really bothered me is that HipChat, CoreChat needs to show you live updates of whenever someone votes for something, whenever someone tags something. So imagine every CoreChat user with the browser open polling Dynamo every second, or even more, to get all that new data. I'm going to quickly exceed my 25 reads and writes per second that Dynamo allows me. So I don't want to spend any money on this, so I had to find another option. Enter GraphQL with AWS AppSync. Now before I go there, I just want to pause for a minute. I've covered a lot of things. We talked about React, and presentational components, and container components, and authentication, and I just want to open it up for any questions at the moment, if someone wanted me to touch on any topics in more detail. Okay, cool. You must not be bored, because you haven't thought of any questions yet. All right. So, what are GraphQL and AWS AppSync? GraphQL is really like the new REST. I'm going to go into that in a lot more depth in a few minutes. And AppSync is AWS's managed service that lets you define GraphQL APIs, and then you can connect those APIs directly to Lambdas, or DynamoDB, or HTTP endpoints, or other AWS resources, all without having to run your own servers. It's pretty cool. And then GraphQL itself also supports the ability to subscribe to APIs and be notified via WebSockets whenever they're invoked. More on that later in GraphQL. Back to my original problem, where I had CornChat directly talking to DynamoDB and fetching items right off the wire. Well, if I introduce AppSync in the middle, the picture looks more like this. CornChat will issue GraphQL API calls against AppSync's managed server. And then AppSync will go and call DynamoDB on my behalf, fetch some items, and then return them back through CornChat. So now this is great, because now my Cognito token that I was getting earlier, it doesn't need to grant me access to DynamoDB anymore. It only needs to grant me access to those GraphQL API calls. And the side benefit here is now all the access to my application is now performed through these API calls, which gives me the ability to get notified whenever someone adds a reaction or adds a tag or removes a reaction. It's a pretty powerful design. So let's dig into the details here about GraphQL. What does that thing look like? So I like to think in terms of from the browser perspective. So here I have the network inspector open for CornChat, where I've loaded up the page, and it is making a request to load some message info. So for each message, there's info attached to like your reactions and your tags. And here's what that request looks like. You see this really long, indecipherable domain name there. That is what AWS AppSync gives you when you provision an API over there. Like, here's the host that you and only you can go through for this API, and make all of your GraphQL calls against it, and we'll take care of the rest for you. Cool. Well, what does the body of a GraphQL API call look like? GraphQL calls are just HTTP. There's nothing else special here. It's not a different protocol. Here's the example payload of a GraphQL call. In this instance, I'm invoking an API called list message infos, where I can pass it an array of message IDs, and GraphQL, the API, will return to me all of the detail associated with those messages. The really interesting part, the really powerful part about GraphQL is that second part of the body there is this query, where I can specify the shape of the data that I want returned. So the message info might return a lot of things, like tags and reactions, and who knows what else I have in the future. But if all I want are just the reactions or just the tag names, I can specify right up here the specific fields that I want returned. If any of you have tried to implement something like filterable fields on a REST API, it quickly gets very painful, especially if you're dealing with multiple levels deep. You have a user account or an employee, and I want to get some of his employee info, but I also want to get its company info. And you have nested relationships, and you end up coming with some pseudo language that you can throw on top of REST just to bring back only the few data points you want. It's really a pain, but this is solved in GraphQL just out of the box. And another benefit, although I won't show it here in this demo, is GraphQL also lets you pull from multiple data sources with just one API call. So like Facebook makes heavy use of this with GraphQL. They created GraphQL originally, so that you can go and fetch user data and message data and all these associated things just with one round trip from the client by specifying your query the shape of the data. So pretty cool. So that's what it looks like on client. When I make that call, the browser, the server responds with a JSON payload that says, oh, here's all your messages, and here's all the stuff in there. You can see it's kind of small at the top of the screen, but there's a little heart eyes emoji. So in this case, there's a HipChat message there with a particular ID, and it returns, you have a heart eyes reaction issued by user 506041. Great. How does it work underneath? Well, when you define a GraphQL API in AWS AppSync, you literally go to the AppSync console. You can do this. You just go there and you click on Create API. In my case, I've already created one called Test CornChat API. If I click on that, it shows me some of the details about it. I'll show you that the important part here is this API URL. That's that domain, that crazy indecipherable domain that we had on the previous slide. This is where all of your calls will go through. So AppSync is provisioning the server on there, and they're managing that resource and making sure that it works as cheaply as Amazon can make it work. So that's at a high level, this is what I get when I create an API. If I drill into the API, I can specify a GraphQL schema. I can also wire it up to different data sources. So let's drill into the GraphQL schema for a minute. Okay. This is the same data from that previous picture, just magnified a little bit. GraphQL is strongly typed. So all of the requests that you make and all the data that you get back, you have to explicitly call out all of the attributes and values and data types that are associated with it. And the benefit of this is that AppSync is able to validate your queries even before it hits the database on the back end. So if I try asking for, instead of a tag, I ask for a piece of corn, it's going to throw an error right away. It doesn't know what corn is. So if I look at the schema, a schema in GraphQL consists of, or at least for AppSync, generally consists of queries, mutations, and subscriptions. So here I have a query. I'll walk you through that query we were just showing in the browser. I have a query called, one called get message info, another one called list message infos. Message info takes an array of IDs and it returns a list of message info, like tags and reactions. Cool. So there's my schema. I can put it right into AWS AppSync. And that's great, but where does the code live to actually resolve these queries? Now, I've defined the structure, but how do I put the code behind it? Well, if we go back to the AppSync console, on the left-hand side, we have the schema, and on the right-hand side is where you define resolvers for your queries. Well, let's take a look at one of the resolvers for the list message infos query. When you go and edit that resolver, the first thing you choose is a data source. I've already got one defined here for my DynamoDB table. If I go and create go over to the data sources tab and click to create a new data source, you can see all the different options you have here. So your GraphQL API can be backed by Dynamo, Elasticsearch, Lambdas, HTTP endpoints. It's really flexible. Now in my case, I'm choosing a DynamoDB table. So once I've chosen my data source, now I can go and specify what they call the request mapping template. It's like the code for what operation you want to invoke on the back end. All right, so let's zoom in on that. Before we do that, so just wanted to call out on the left-hand side is this request mapping template. On the right-hand side, because I'm using a DynamoDB data source, AWS gives you all these really nifty sample templates that you can use. I didn't have to figure out all that code initially. I could just pick a template from the drop-down list, and it's usually roughly correct to what I want it to do. Let's zoom in on that code a little bit more. It's easier to see. All right, so for a DynamoDB resolver, you basically need to return a JSON specifying which DB operation to perform. Now in this case, I'm calling batch get item on that test corn chat message info table, and I'm passing it a map of message IDs. All the stuff at the top is basically just trying to convert an array of message IDs into a map of message IDs. I wanted my GraphQL API to accept arrays. I probably should have it accept maps, a little bit easier, because writing in this language, this is called Apache VTL, V something template language, it sucks. This is not a fun templating language to write in. It operates kind of on Java objects, like see there's like a toString there that you can call Java, but then they overlay all these. Anyway, it's kind of a mess, and debugging it is impossible. The best I could do to debug this thing was to like append errors into my response objects, and then look at the logs in AWS CloudWatch or in the browser to see, like, try to reverse engineer how the hell this thing works. Anyway, bottom line. If you have to have a lot of resolver logic, you're better off putting that into an AWS Lambda and getting out of this template business as much as you can. In my case, I'm doing some pretty simple operations, so it wasn't too bad. All right, so back to that resolver screen. So I figured out the code. How I want to call Dynamo. And you can specify one other thing at the bottom. It's called a response mapping template. And this allows you to define what you want the payload response to look like in the browser. So I fetched all this stuff from Dynamo, and I want to shove it inside of a map called items. And get items map and everything. Great. So just tying it back to what we showed earlier. The browser makes this request, calls this GraphQL query, specifies all the message IDs that I want to fetch, the shape of the data that I want returned, and GraphQL responds with what I asked for. Cool. So that's GraphQL queries. I'm going to talk about mutations next. But are there any questions up to this point about any of that walkthrough? Okay. All right, GraphQL mutations. So let's walk through a use case where I add a reaction to a message. So I want to add a heart eyes emoji onto a particular message ID. It looks really similar to that query example. A GraphQL mutation is just another query, except instead of being called query, it's a mutation query. So the mutation query looks like a function. I have a function here called addReaction that takes a message ID and a string. And you also notice at the bottom, just like in my queries, I can define the shape of the data that I want to come back in the response. When you add a reaction, it returns back to you the message that it updated with all the parameters it updated. I can return all the tags, all the reactions, or I can just say, I don't want any of it. Just leave it out. I don't care about the response. As long as it's a successful response code, I'm good. Now, what does the schema look like to support a mutation? So again, at the top, we have our queries, we have our mutations. I've cut out all the type information that we showed in the previous section. I've got two functions here, one to add a reaction and one to remove a reaction. And then I hook up resolvers, just like we did before. So I'm in the console, I create a resolver, and in this particular one, I'm invoking a different operation on Dynamo. I'm calling the update item operation, and I'm adding these new reactions into it. There's a little bit of ETL code at the top that says, it basically just concatenates my HipChat user ID with my emoji. There's about 50 lines of code above this that figures out how to get my HipChat user ID from my AWS Cognito token. It's a pain, but it's doable. So this way I'm making sure that I'm really getting the right user ID and not just somebody faking that. Cool, so that's a mutation. And that. And lastly, I'm going to show you what I think is the coolest part about GraphQL and what really helped me save all of that money, not having to invoke Dynamo directly from the browser, is using a technique called subscriptions. How do subscriptions work? So at the top here we have CornChat invoking AppSync with GraphQL API calls, right? This is just saying, get me some items, maybe I'm mutating it, I'm saying go and add some reactions, remove tags, add tags. And in parallel, CornChat in the browser opens up a WebSocket connection using the MQTT protocol. And it's like a dedicated line to AppSync. And anytime AppSync observes that any of my API calls are hit, it can notify me on WebSocket to say, hey, something just happened. And this protocol is really lightweight, and it's very, because it can be really chatty with all the notifications going back and forth. But generally speaking, once I get a notification that something has changed, it'll even tell me what changed, what, somebody added a reaction, it tells me what message it added, where it added it to, so I can update my UI. Because I was curious, I wanted to see, what do those WebSocket connections look like in the browser? It's a completely different, it's hard to see it right here. A little bit. Okay, well this is the request URL. So this is how you open up a WebSocket connection to there's my AppSync domain. And instead of hitting /GraphQL, I hit /MQTT. And this establishes a WebSocket connection. You can click, it's hard to see it, there's a tab called Frames. If you're interested, you can see all of the WebSocket traffic going back and forth. Now, internally, I didn't actually have to hook up any of this myself. I don't know how to write a WebSocket and speak MQTT protocol. But thankfully, I found a library called Apollo, which is really, one of the leading libraries for working with GraphQL, especially in an environment like React. It doesn't have to use React with it, but it makes a lot of this stuff very, very simple. Some really good functional patterns you can use with Apollo. So if you want to use GraphQL, I recommend looking into Apollo to make that work on the JavaScript side. Great. Now, what do my subscriptions look like on the back end? So again, I have my schema, I've got queries, mutations, subscriptions, and at the end there's a subscription, and there's this magic directive called AWS subscribe. So when AppSync parses my GraphQL schema, it sees this and says, oh, I got to do something here. I've got to be ready to listen for WebSocket connections. And when one comes in, I need to let them know anytime the add reaction or remove reaction APIs are called. And that's it. There is no other code you have to add on the back end. It's just 4 lines, if you can't break the line break there. It's like 4 lines of code to get subscriptions fully hooked up on the back end. Really powerful. And you may be wondering how much this stuff costs. And it's not a lot. I mean, if in some crazy dream universe, I had 2,500 HipChat, CornChat active users using it for like 40 hours a week and sending, I think it's like 1,000 CornChat messages and reads and writes, it would cost me like $17.13 a month to run it. And the WebSockets portion of that it's like $1.93. You can have so many of these concurrent connections. AWS has really figured out how to make this stuff scale. So pretty cool. All right, we're in the final stretch here. There's one more technical topic to show you guys. Should be pretty quick. Thank you for sticking with me this long. Oh, you have a question?
I have a question about the subscriptions. I'm wondering, does that have filtering capabilities beyond just showing which messages you want? Say, you want to filter based on the room you're in. That's it.
Yeah, so I was asking about with subscriptions, are there additional ways to filter what's coming back, like based on the room that you posted to? Yes, you can. In fact, I'm actually filtering on the rooms in the real CornChat. I simplified it for this demo, but you can specify specific parameters, like in the case of a room, and so that anytime if you only want to subscribe to like the CornChat room, you can do it. It does complicate that subscription line a little bit more. And in the query side, you have to specify the parameter values that you want to filter on. But it's really, really straightforward. And there's no extra code involved there other than just describing it right, because AWS already has the APIs and all the parameters coming in, so they know how to map it. Jesse?
So as far as hitting GraphQL, are you getting like what kind of responses do you get back as far as like do you get like 200s and 201s, or is it just like success or fail?
So with GraphQL, what responses? The question is, what responses do you get back when you make a request? You get HTTP response codes that tell you. I think you can get like 422s, for example, if your schema, the query that you specify is malformed or you're asking for things that don't exist, it does return the right expected HTTP response code in that case. And then you get back, anytime you ask for data, in addition to the 200 OK, you get the data you asked for. Does that answer your question? Cool. Yep. Any other questions about GraphQL? So last thing I want to talk about deploying CornChat. Now, CornChat doesn't run on a server. There's no application running anywhere other than AWS has AppSync, so it's doing that for me. AWS has Dynamo, it's doing that for me. I've got a Lambda, but that doesn't run until it's invoked. So there's no server to deal with, but there's a whole heck of a lot of AWS stuff that I have to configure. I've got to specify my GraphQL schema, and I've got to specify all my resolver code, and I have to specify all of the I didn't talk about it here, but there are also IAM roles and policies that you have to configure to let, for example, Cognito be able to talk to Dynamo or what have you. So initially, when I tried to deploy CornChat, I first started out using just shell scripts and just bash this together. No problem. I'm already using the command line to update my schema. I'm just going to put a shell script together. I'm going to call it deploy.sh, and it's going to be great. And it starts to get more complicated, and I start building a framework around how to deploy something. This is bananas. There's got to be a better way, and there is. There's a tool called CloudFormation that AWS gives you, where essentially you specify a YAML file. I'll show it in just a second here. You specify a YAML file of all of the AWS assets that you want to deploy, and then you run one command. It's like AWS stack deploy. And it'll just provision all of those resources for you, and it namespaces them for you. So I have like n number of test environments I want. I've got test CornChat, I've got like a dev corn chat, and I've got like, I'm just trying this crazy idea corn chat, and I've got finally the prod corn chat, which is where everything really runs, and I don't want to mess that up until I've really tested it right. So it's pretty cool. You basically get like free environments. You can just spin them up, tear it down as you need to. So what does a CloudFormation template look like? It's quite a bit of code. I'm not going to show all of it, but I'll show you some of the interesting parts. For example, here's my Cognito setup. And scroll down. Here's my GraphQL API. That's pretty interesting. Here's where I define my data sources. But the part I really wanted to show you is, these CloudFormation templates get really long, and AWS doesn't provide any out-of-the-box ways to make it easy to stitch these things together. You can sort of include another template, but it's not easy. And what I really want to do is, like I said, I don't mind that I have all of my IAM roles and policies and basic AWS setup in here, but I really don't want my GraphQL schema and my mutations and my resolver code to live in the same file. I just feel like it's too much too many updates going on there. So I found a very low-tech solution here. It's this really great program. It's called ESH. It's got very few stars on GitHub, but I think it's a real gem out there, especially for side projects where you're not building a whole framework. ESH is really simple. It lets you put this bracket % token in a file, and you can write any batch that you want in the middle. And you just resolve it. You just say ESH this YAML file, and it will substitute the output of that command right into the file. So in this manner, I was able to cap the contents of my schema, which is located in another file. I did some sed magic to put the right number of leading spaces before each line, so to have all the YAML indentation right. And that was it. It was like so quick to get that set up. Really great tool, and it helped make my CloudFormation template a lot easier to digest. Also, I kept my Lambda code separate, and I have a separate bash script that just uploads those to S3. So I didn't want to put my Lambda code directly in the YAML file. Cool. All right. So we've covered a lot so far. We've talked about reverse engineering HipChat, about React, and AWS, and Dynamo, and Cognito, and AppSync, and mutations, and subscriptions, and queries, and CloudFormation, all these really cool tools. But there's one item in the agenda that I didn't cover yet. That was curing cancer. All right. So my daughter Quinn spent the last 8 months at Boston Children's Hospital fighting acute myeloid leukemia. And thanks to doctors and nurses and volunteers and family and friends and coworkers, I'm very happy to say that Quinn is alive and healthy and home. So while I was there, I built Corn Chat over the course of like April and May, really just at night on the hospital Wi-Fi. And so I just wanted to say, if you found Corn Chat useful or anything about this talk useful, please consider donating to Alex's Lemonade Stand charity. They are a nonprofit that directly funds local researchers who are fighting to cure pediatric cancer. Some of the researchers and projects they funded, they directly funded some of the doctors that literally saved Quinn's life. So they're doing great work over there, and there's a link to donate. If you're interested in this, there's a link to donate at www.cornchat.online. That's also where you can find the source code for Corn Chat and how to get the application up and running. It's in alpha stage. It currently has a bug where it crashes after an hour, but I'll get fixed soon. Thank you. Yep, we do still do matching, up to a couple $100. So if you do match, we haven't done any donations this year. You fill out a quick form through Endurance, and they'll double what you put in.